Hello all, this is a computer science class and today we are going to begin the Unity 7, the unity which talks about process management and scheduling algorithm. So in this unity, by the end of this unity, everyone would be able to explain how processes are managed by the operating system and to understand process scheduling algorithm. So to begin, we need to understand what is a process. When we say a process, what do we mean? So by definition, a process is a program in execution. So that means if a program is being executed, so we call it a process. It is an instance of program execution and is not as the same as program code, but a lot more than it. So here we have two words where we have a process and we have a program. So when you have a program, two parts of a program or three parts of a program can be executing at the same time. In that time, we call it a process, which means a process is bigger than a program, because a program can have sub-programs. So a process is an active entity as opposed to a program which is considered to be a passive entity. What that means? So a process, as we have said, the process, we call a process as a program in execution. So which means it is being executed at that moment. While a program can be in execution or not in execution. So that means when a program is stored on a hard disk or on a storage, it's there but not in execution. So we call it a passive entity. But we call a process only if the program or the part of the program is being executed. In that case, we call it an active entity. So attributes held by the process include hardware state, memory, CPU, and other different resources, as we are going to see it in the next slides. So when we say a process memory, because the process takes place in the memory. So the process memory is divided into 4 sections for efficient working. One section is text section, we have data section, we have heap section, and we have stack section. How are they different? So the text section is made up of the compiled program code written from non-volatile storage when the program is launched. So when we are writing a program, we write a source code. Then the source code needs to be compiled to be understandable by the computer language or the computer system. So which means it is changed into computer understandable language. So when the program is in execution, we call it a process. So in that case, that code is compiled, and when the program is not in compilation mode, it is stored on a hard disk or on a given storage. So now when we launch or when we open that program from passive mode to active mode, now we call it a text section. While data section is made up the global and static variables allocated and initialized prior to executing the memory. So when we are writing a program, we declare variables. Some variables are global, others are static variables. So When the program is in execution mode, so it uses either global variables or static variables to store values, or the values may be stored prior to the program execution. So in that case, we are in data section. Then the heap section. The heap section, these are physical or virtual components of limited availability within a computer system that are needed by the process for its execution. So this includes CPU time, it includes memory, which is random access memory as well as virtual memory. We have also secondary storage like hard disks, external devices connected to the computer system. So the heap is managed via calls to new, delete, malloc, free, and so on. So you remember we have seen these keywords in C++ while we were discussing about pointers and memory, dynamic memory allocation. So the heap here include resources, either internal resources or external resources. So the program or the process to complete its task may require, for example, a keyboard to be connected. It may require an external hard disk to be connected. So when such resources are being managed or are being required by the program, so they are managed by the section we call a heap. Another section is the stack. Stack is used for the local variables. So space on the stack is reserved for local variables when they are declared. So writing a program requires you to declare some local variables which can store values during the program execution. So this part is managed by the stack. So here the graphic or the figure shows those four sections. As we can see here, we have the stack, here we have heap, here we have data, we have text. So when you say about text, so these are records which have been compiled. Then with the data we have global variables and static variables. With the heap, here we have dynamic memory allocation using keywords new, free, and others. Then while in stack we have temporary data which are stored in the local variables. All are here are found, or they meet in this space that we can call like a CPU, the place where the execution is going to take place. So hopefully we understand well the process. Now, the process being executed or in execution, or a program in execution, requires some resources. The resources required by a process to execute includes central processing unit, which is a CPU. It includes memory. It requires memory, which is RAM or random access memory. Also, it requires input and output device to supply or to display the values. So in current computers, several processors share resources where one processor is shared among many processors. We can have, we currently have what we call multitasking computers, which can which can execute many tasks or many processes at the same time. So we call that multitasking systems. Here we can have a CPU which is taking many tasks at the same time. The CPU and the inputs and output devices are considered as active resources of the system, as they provide input and output services during a finite amount of time interval, while the memory is considered as passive resources. What that means? So the process happens only if the program is in execution. And when the program is in execution, necessarily requires the input, requires the output. This also it requires the CPU, which is of course is working on the instructions, so that the computer can know what each and every line means to the computer. So we call them active resources because they are required by the computer or the process to take place. While the memory is considered as a passive resources. There may be time when a process is not in execution mode and the computer is sleeping. So in that case, the memory is doing nothing. So sometimes the memory can be doing something, cannot be doing something. So in such case, it's a passive resource. So a process is executed by a processor through a set of instructions stored in the memory. This instruction processing consists of two stages. We have the processor read, which fetches instructions from the memory one after another and executes each instruction. The process execution consists of a number of repeated steps of fetching the process instructions and instructions execution. So the process of a single instruction is what we call instruction cycle. So if you remember in Senior 4, we have discussed what we call we've called that EI time, and we have what we call E time. So how the CPU works on the instructions or execute the instructions. So I time, we call it, this is the instruction time, while E time is what we call execution time. In E time or instruction time, this is a time where the CPU gets instruction to be executed from the memory, try to understand by decoding the instruction, then give it to the CU, control unity, or to the ALU, depending on what the instruction is designed to do. Then the CU and ALU is going to understand or to do what the instructions has to do. That time we call it execution mode. So basically, each time has two phases: fetch instructions and decode instructions. So in decoding the instruction, so the CPU try to understand what the instruction means. While in each time, there will be the execution of the instructions. Then after instruction is being executed, then there will be storage of the output, or it can return back the instruction or the output to the main memory. In that case, now the instruction will have been completed, and the async instructions after being executed, it's what we call instruction cycle. So hope you understand that. So next we are going to compare what is a process and a program. By definition, we have said that a process is a program in execution, while a program is defined as a piece of code which may be a single line or a millions of lines. A computer program is usually written by a computer programmer in a programming language. For example, here we have a simple C programming language program, which does what? Which prints the message hello world on the screen. So we call this a program. The whole of this, we call it a computer program. But this is a source code. Then this source code need to be compiled so that the computer can understand what this code means to the computer. Then after compiling this program, the program is going to be compiled, then you run it. When you run, means it's in runtime, and that part which is learning, it's what you call a process. And as you can see, this program will only print the line hello world only. So, and it is made of how many lines? We have 1, 2, 3, 4 lines. So, and we call this a program. So a computer program is a collection of instructions that perform a specific task when executed by a computer. When we compare a program with a process, we can conclude that a process is a dynamic instance of a computer program. A part of computer program that performs a well-defined task is known as an algorithm. So a collection of a computer program computer programs, libraries, and related data are referred as a software. So to understand this, the entire program may not execute at the same time. A computer program may have parts which is executing and another part which is idle, which is going to be executed only when it is invoked. So in that case, that part which is not yet invoked, so it's not yet a process, but it's a program. So which means a program can be executed into different processes. So here I have some comparisons. So a program consists of a set of instructions in a programming language, while a process is a sequence of instructions in the execution. A program is a static object that exists in a file, while a process is a dynamic object, means a program in execution. A program is in the secondary storage, it is stored in secondary storage, while a process is loaded into the main memory. The time span of a program is unlimited, meaning that as long as the program is open, it is considered to be running even though it is idle. There may be some part of the program which are not in execution, but they are in running mode. So the time span of a process is limited. So the process has a time it begins and the time it ends. We'll see that in process scheduling. A program is a passive entity which exists in a secondary storage persistently even if the machine reboots. So the program would be stored in a secondary storage even if the computer is on or not. But the process is an active entity since it is always stored in the main memory and it disappears if the computer's power is switched off or has finished the execution. So now here we are going to discuss about process states. So the process, when a process executes, it changes the state, whereas a process state is defined as the current activity of the process. A process can be in one of the following 5 states. 1. New. The process is new when the initial state, this is the initial state, when a process is first created but it is not yet been added to the pool of executable process. So for example, when you launch Microsoft Word, well, the time you see the banner of Microsoft Word, so that means the process is being initiated. So it's a new process or a new task being initiated. Then the second state is ready. At this state, the process is ready for execution and is waiting to be allocated to the processor. So at this time, the process has been created, then it has been done to be initiated. So Microsoft Word, let's say Microsoft Word is already open. But while it is open, there may be other programs in execution. So when that word is opened, we'll wait until the processor is ready for that Microsoft Word. At that time, the process will be in ready state. So already processes are kept in a queue and they keep waiting for the CPU time to be allocated by the operating system in order to run. A program called scheduler picks up one ready process for execution. So which means every program we open doesn't immediately go in this execution mode or in the CPU. So it will the program called scheduler will create a pool or a queue according to the time each process has been created or has been launched. Then when one in the CPU finishes, another will take place, and so on and so on until all the program launched has been executed. Then the process is waiting for some event to occur before it continues execution. The event may be in user input or waiting for the file to become available. So in this time, the program may be in execution but need some input resources or need some other external resources, like for example, you are typing, you have the Microsoft Word in execution mode, you are typing but the keyboard is not responding. When the keyboard is not responding and the Microsoft Word is already in the CPU, so the Microsoft Word will be put in a waiting state or in a waiting mode, waiting the keyboard to respond. So in that case, it will be in a waiting state. So terminated, this is when a process finishes its execution, and in that case it goes back to the main memory. A process terminates when it finishes executing in the last statement. When a process terminates, it releases all the resources it had and they become available for other processes. So which means if the Microsoft Word were using the keyboard and it has done execution, so it will release all the processes. Then it will release all resources, and the resources will be available for the next execution. So the next slide is now it's an image that shows the state we were discussing, and here the process can be in one of the 5 states as the image here shows. So we have a new process. Then when it's done launching the new, or it's done creating a new process, the process is admitted to a ready mode, and in the ready mode here there may be the scheduler here is going to put it either in running mode if now this ready process requires some input and output or some event to complete, so the running will be interrupted, then be put in a waiting. Then when it becomes ready, it will again be put in a running mode. Then it may be in running mode, then here, and after being in running mode, it can be terminated, means if it is completed, and so the process will be like this. So the process is created, then after being created is going to go on ready. Then in ready, the scheduler will put it in running mode. If it may be in running, then it requires some input and output or event wait, so it will be put in a waiting mode. Then when it is ready, it will go in ready, while then it will be put again in running mode, and the circle will be like that. When it is complete, then it will go in a terminated state. So now the process is managed and is controlled, and here we are going to discuss what we call the process control block, or what we call PCB. A process control block is a data structure which is maintained by the operating system for every process. So which means each and every process created has what we call a PCB. Again, it is called the task control block, and it is a storage for information about process. So it stores the information about the process. So when a process is created, the program or the operating system creates a corresponding PCB, and when the process terminates, its PCB is released to the pool of free memory locations from which new PCB are made. A process can complete for the resources only when an active PCB is associated with it. So to give an example, let's launch the task manager and see how the PCB looks like. Now let's launch task manager by holding Ctrl-Alt-Delete, then go to Task Manager. So in Task Manager, here we have the apps running and the background processes. So those are the tasks, or these are the processes. So each process shows this CPU it's using, the memory it is using, the disk storage it is using, if it requires a network to take place. So all those are information about each and every process. So now let's take an example of this process, and here you can end the task. Okay, let's go. When we go to the resources value, you can see the memory it uses, the disk, and so on. So now let's come here to the details. When you go to the details here, it's where you will see each and every process in execution. So for example, if we take an example of PowerPoint using here, this is the PowerPoint. So it has a PID of 9188. So this is a process ID. So, and you can see it is in running. So this is the username. So this is the CPU using the so which means in memory in the CPU it's not taking any space in the memory. Then here it is using this memory 50,456 kilobytes, and here it depends on the computer platform you are using. So but here this is what we call a process table, or the PCB. It shows the PID, the status, the username, the CPU, and so on and so on. So let's see here. Let's see the table which maintained by the PCB. So each PCB maintains the process ID or PID. So this is a unique process number that identifies each process. Then it shows the process state, where it shows where it's in running, it's in new, it's ready, or if it has been terminated. For example, if we can see here one process, we can see some processes which have been terminated. For example, this was suspended, this suspended. When you go through, so all some are running and others are suspended. So but when you come here, for example, in the users, so there's space where you can see the program is here in services. There are some program which have been stopped. You can see this has been stopped. So others are running. So this shows the status of each and every process in execution. So another information recorded in the table in the PCB is a pointer. The pointer, this is a pointer to parent process. A parent process is a process that creates another process. As you can see here, if you go back to control to task manager, you can see, for example, in PowerPoint here I have some other processes. You can see I have operating system, I have PowerPoint, but this is also a PowerPoint, but here you can see this one is a slideshow, another is a PowerPoint. This is a slideshow, this is a PowerPoint. So each can see each process create some other sub processes. So which means this is part of this, this and this. So this it's a pointer. We have the program counter. The program counter contains the address of the process next instruction to be executed. So there may be some sub-processes, and the scheduler will know which sub-process comes next, so that will be a program counter. We have CPU registers, which include the accumulator and index number, index registers. So whenever a process switches from one process to another, so it is maintained or it is recorded by for example, the program may be waiting for some resources to be available, so it may be swapped out and put out of the memory the CPU, and another program takes place. When the program becomes ready, then it will be swapped in and come back to the in the CPU. So this is managed by the CPU register. So we have another the information about so here we mean from one process to another. The information about the current status of the old process is saved in the register along with the program counters, so that the process can be allowed to continue correctly afterwards. So this is what I was saying. So input and output status information, this includes the name of input and output devices used by a process, list of open files, and the information about allocation of the peripheral devices to the process. So this will show every input and output device a process has used. It will show if you have included some files, it will show the opened files and some other information about peripherals devices. Also, the PCB records or contain accounting information. This includes the actual CPU time used in executing a process. So it will show this process has started at this time, it has been ended at this time. Also, it includes processor scheduling details. So this includes the priority of process and the address to the scheduling queue. So we'll get to understand this well when we'll be discussing scheduling algorithms. So each process, there are some processes with high priority and others are of low priorities. So when a process of high priority comes, so the one with low priority will swap out, and the one with high priority will swap in. So in that case, the processor scheduling details will record this information. These were being executed, but it did not complete. Then it will swap it out, and when the one with high priority finishes, that one which was stopped will come in and finishes its time for execution. So that will be managed by, will be stored in processor scheduling details. So this is all about process control block, and these questions have been sent to you prior to this lesson. So hope you got to answer to all questions. And if you have any question, so feel free to text me either via WhatsApp or Teams or using any platform that you are comfortable with. So, so this lesson was about process, to get to understand what is a process means, and how is it different from a program. And we talked about PCB and the table that is decoded in the PCB for each process. So any question, feel free to reach me. Next time we will discuss about threads. Thank you.